Hi, I've got a real interesting bit of kit for you today. This is a Cadence C7000 a commercial battery analyzer, 4-channel jobby. Look at this. This is a serious bit of kit made in Canada. Thank you very much. Hi to all my Canadian viewers. So this is a commercial analyzer designed for not just production batteries, but also like in-service batteries, return batteries, things like that, to actually not only analyze their capacity in milliamp hours or watt hours, however you want to do it, but also to rejuvenate cells based on the various chemistries and stuff like that, and do all sorts of analysis functions. And it's a real serious bit of kit with a real serious price tag, and it's got these really absolutely fascinating with universal adapters with these pogo pins on it. As you can see, it's 4 channels, so you can test 4 batteries at once. And this is an 80 watt version total, but I think you can do like up to 55 watts per channel or something like that. And of course, it can discharge as well as charge, and it can do lots of fancy like production and automation type stuff. Like if your batteries have got serialization in them, it can all be programmed. If they've got battery gauges in them, like you can calibrate and recalibrate battery gauges built into batteries, also known as Coulomb counters and other things. You can do all sorts of fancy stuff with this. And the amazing thing about Cadex, they're probably the duck's guts on the market. They've got over 3,000. I think there's actually over 3,200, they claim. 3,200 different adapters that you can plug into just this series. This is not their only series. They've got, much bigger ones and fancier ones. And if you're a manufacturer, I'm sure you could approach them and, say, hey, we've got this custom battery in our product. Can you, design us an adapter that fits inside here that simply fits our battery, fits our product? And I'm sure they got, tons of other configurations. A company like this that specializes in battery analyzers pretty much, then, that's their only business. And these are real expensive bits of kit. So it looks like it's got a 2-line, probably 40-character LCD there, and it's got 4 channels, as I said, and it can all be automated via a PC and software, and you can get graphs, and you can do, programming into this, and then, the operators on the line can just, press the buttons and do whatever you need to do it. So I don't know how much stuff you can do on the keypad here and how much stuff has to be done in, PC software, a menu and stuff. I'm sure we can do some basic stuff. You can see the adapter here. I'll probably take it out and have a better look. But it supports all different types of chemistries, although curiously, this one says, warning, not for use with lithium batteries on C7000 BOS. I don't know what the BOS stands for, but this series does support lithium batteries, so I don't know why just having the universal pin adapter in here would be a problem. But anyway, you can just lift those out like that. It's just got a card edge interface. The whole idea with these is that you don't use universal adapters like this unless you're testing like many different types of batteries all the time or something like that, or you got something oddball that, you don't have an adapter for. The whole idea is that you buy an adapter that plugs in that suits your specific battery. And on the back here, it does have some sort of, module or something. I don't know what that does. It may be like automation or something like that, some sort of production automation, interface, relay, I/O interface, something like that, perhaps, I can imagine. RS-232 serial interface, and made in Canada. Hi to all my Canadian viewers, and it's built like a tank, and it weighs a lot. None of that switching rubbish. This thing's only 115 volts only, so I assume like there's a big linear transformer in this. It'd want to be. It's bloody heavy enough. So yeah, I really like the design of this universal adapter. Actually uses DC barrel jacks like this, and these just pull out like that. So it's just like a little 2mm pin interface, and so you can replace the probe tips, and then they just slot into there, and just the DC barrel jack just goes into the positive and negative down there. Yeah, well, why not? DC barrel jack adapter. It's cheap, it's simple, they're relatively robust, but I love how they've how this arm works. Like, it's springy loaded like this, because when you've got spring contacts like this, you do want them to come down with like a little bit of force, so that your pins make contact, so you don't have to hold them down with your hands. So I guess the whole idea, this one is, I guess, designed for like maybe like a vertical battery comes out here. It has like the contacts on the top, and then you can like separate these to the distance you want, like that. It's got a little spring on the bottom, but you can still move them a little bit. But yeah, you press on that, slides back and forth, and then they just latch over in place like that at set distances. It's very nice. And then you can just put that on top of your battery. That's really cool. I don't know if they make like different types of universal adapters. I don't know. They've got like over 3,200 adapters, but that's incredible. Anyway, let's tear this down. Anyway, you know what we say here on the EV blog, don't turn it on, take it apart. Let's start out with this battery adapter. I don't expect much in here. Maybe it's got some protection or something like that, because I think all the goodness is going to be inside the analyzer. I mean, the analyzer itself is going to support all different, voltage and cell configurations and, stuff like that, series and parallel arrangements and stuff. But so that's a 6-way contact on each side, so 12 contacts. Didn't expect much. There's a little tiny fine wire going over there. My guess is that is a temperature sensor. It's going to be a thermocouple, but yeah, there's basically nothing in there. Didn't really expect it. It's just basically a mechanical interface. And it does have a 4-wire interface, so it's not just red and black. So they're obviously tapping the voltage back on that. So that's what they're using the barrel jack for. The extra pin there, because the 2-pin barrel jack is not used for like shielding or anything like that. It's used for feedback. So they're feeding back. It's a 4-wire measurement. They'd be feeding it back right on the pin there. So you're not getting any voltage drop along the cables. You absolutely need that for any professional or even, semi-professional battery analyzer, especially for any serious amount of current. You get, significant drop on your cable, and that's going to ruin your day. And, if you're talking about, touchy chemistries like lithium ion, for example, the voltages are really important, so you can't have any drop on there. So what's on the back here? Is there anything on the board? Yep, nothing. They've put some large diodes for some protection there, but they haven't fitted those, so I don't know. But wait, there's more. They do, complete with cobwebs. No, they do have something on there. By the way, you can see that the thermocouple wire just goes directly back, soldered into the board there. None of that connection rubbish. What chippy is that? Aha, that makes sense. Yeah, nothing to do with the charging at all. It's just the E² prom, so it has the ID, so that the software and the device knows that this particular module's plugged in. And yeah, with over 3,200 of them, yeah, you want it to auto-identify when it just plugs in. And then it'll know that, okay, that one's designed for this particular battery with this particular cell configuration and this particular chemistry, etc., etc. And I'm sure they'd design you a custom one of these, because, there's no way they're just going to, off their own accord, design 3,200 different interfaces. I'm sure that comes about because every manufacturer of every little mobile product with a removable battery has come to them and said, hey, we want an adapter for it. So they add it to their inventory, and presumably anyone could buy it. And presumably you could probably get an adapter that plugs into both at the same time, it's wider. They do have some basic instructions for using the keypad interface on this thing. But yeah, as I said, a lot of this is just all pre-programmed production type stuff. You don't you basically, trust me, as someone who comes from a production test engineering environment, you never want the operators to have access. I wouldn't surprise me if it's got a lockout code and stuff like that. So, you can't have the operators dicking around with this, because trust me, they will. So ventilation on this thing, just a fan here. There's a bit of ventilation on the bottom. That's probably, I reckon there's yeah. I can see some points for a big mains transformer in there. So I reckon there's a big bulky mains transformer there. So that's just the vents for that, and they've just got the vents along the top here because, you know, it does a reasonable amount of power. So this is 2005 vintage, so I wouldn't expect any like modern ARM processor or anything like that. And of course, it would date back. There'd be a lot of history in this company, and I'm not sure when they started, but I'm sure it was way before then. They would have, of course, had their own in-house, you know, favourite processor, and they probably stuck with it, probably even today. So it wouldn't surprise me to find like a Motorola jobby in here. No, something's... Oh, no, there we go. Oh, we're in. Oh, dusty. Oh, this definitely needs a good blowjob. So, yeah, I'm going to go do that now out in the stairwell where all best blowjobs happen. Yeah, I'll get back to you. There's the LCD and keypad assembly, designed in Canada, upside down, so all the electrons are going to fall out. They're quite proud of the old designed and made in Canada, aren't they? There you go. But that's a pretty large main board. It extends the entire depth of this thing. And there's your firmware. I don't think this is updatable remotely. I think, yeah, you have to pop in a newie down there, but yeah, I like how they've very deliberately put it down here so you don't have to take all the rest of this assembly out, which, yeah, presumably, I don't know how the rest of it comes out, but you don't have to take that out, yeah, to access and swap the ROM down here. So, yeah, very nice. I love how they got that right angle latched IDC ribbon connector as well. I love how they've done their LEDs down here too. No need for light pipes or anything fancy like that. Just have a cutout in the board. Just solder your LEDs on like that. You can get reversey middle ones. But anyway, they just poke through the decal on the front, the clear window there. Nice. Looks like, yeah, I have to undo these. So these would be, would these be metal threaded studs in the PCB? We'll find out. And they just lift out of there. And yeah... Somebody dropped a pin. I was just about to admire the design here, how this would hinge out, because there's two nut and bolts over there. They're threaded into the chassis. It's not like you can undo them from the outside. And yeah, no, it doesn't, because the connector's in the way. Oh, wah. Why can you make the cutout a bit bigger and just swing that out? Oh, well, it's the next best thing in that it lifts out like that. And the screws can stay in place, so that's okay, I guess. I don't know, I just wanted something to swing out, please. So anyway, there we have it. That's pretty sweet. One large board in there, and even the transformer made in Canada. ATC Frost, are they still in business? Leave it in the comments down below. All my Canadian viewers, I'm sure they'll know. Bit of rust on there. Now, what I find interesting is that I expected, like, a total of 4 like power channels, and of course, like we've got 4 chokes here. Are they? Yeah, there are 4 common mode chokes. So that's 4 switching something or others, right? We've got some switching trannies in there like that, little surface mount jobbies and stuff like that. But interestingly, we've got 2 heat sinks like this, so we'll have to find out what they are. I don't think they're anything serious, but look, we've got 7 vertical power resistors like this right next to the fan. They're so close to the fan, so I don't know what that does to the thermals of this thing. But anyway, okay, you want to get the heat out? All right. Yep, let's put it right next to the fan. Geez, yeah, they're a little bit tight for space in this sort of thing in the end, but because they went for the whole single board construction. But yeah, I don't know how those 7 are related to the 4 channels, because I believe all 4 channels are identical specs, and looking at all the other circuitry in there, it looks like all the sensing and everything else, all the, you know, switching and whatnot, is the same for each channel. So these, I think, 2 power transistors, or there's a sneaky one on the bottom. Let me get my head under there. Yeah, there's a sneaky device on the other side. Okay, that makes more sense. All right, so we've got 4 power transistors, 2 on each heatsink. They're all insulated with a sill pad. Nice little clip that just presses down on there. Nice. None of that screw rubbish. Excellent. Aha, I was just about to say, these heatsinks aren't going to be the series pass transistors for the electronic load, which I've done a video on, by the way, because if it was, then you wouldn't have such large power resistors like this for measuring currents sense. So obviously it'd be these transistors here, which then, where's my probe? These transistors here, which would then be used as the electronic load for the dissipation in the big resistor there. So yeah, that's what they're doing. But once again, why 7? I don't know. Yeah, so that's only a LM317 in there, adjustable voltage regulator, so I assume the same on the other side and the other two as well. Yeah, because these heatsinks are just like mounted completely wrong for the thermals of that fan, so yeah. Oh. Yeah, I don't particularly like the thermal arrangement here. Look, they've even got them staggered. So like when the air, like, you know, the air comes through like this, it's then got to go up like this and then out like that. When you block it like that, that's a real problem. You want to have them lined up so it at least flows, you know, relatively unrestricted over the surface. It's not goes in here and goes bang, oh, I've got to go here, around here like this. No, that's a bit of a fail. So I don't like that. And of course the heatsink orientation, you want fins in this direction, going like this. So, and you want the airflow over the fins. You don't just want to blast it right on the on the surfaces like that, because it just gets stuck. It's got nowhere to go. So the thermal design of this, yeah, gets a thumbs down. And we've found our culprit down there. Yep, Motorola, I called it. HC11 jobby. What's that? Oh, that's version 1. So that's, I don't know, is that like a boot ROM or something like that? Anyway, all fairly discrete stuff happening here, which, yeah, you'd typically find in something of this age. And then we've got a CPLD down there, do we? Or two of them. They kind of look CPLD-y, something like that. But, yeah, anyway, and then we've got all the stuff surrounding each socket, and they're going to be identical. Spot the difference between each channel. I don't think you can. There's a relay in there, genuine Omron jobby. No cheap rubbish in this. And yep, they're all going to be absolutely identical. So, okay, we've found our DAC down here. Well, one of them. Anyway, there's another one. This is a octuple DAC, but it's only, which means 8 of them, but it's only a 6-bit DAC, so that's interesting. But up above it here you go, we now have another a dual 8-bit DAC. So why they've got 2 there plus an octuple? So I'm guessing because that's only a dual, and well, as we saw, the bays in this thing, these bays were kind of sort of physically tied together. So I guess there's only one 8-bit DAC per double bay, and then this one here with 8 channels, 6-bit jobby. I presume that'd be setting the voltage limit and also current limit as well for both of those, for each channel. So that's why they need 8 of them. So yeah, I can't see any others in there. So that's it from the DAC side of things. Now we need to find the ADCs. Now this Linfinity part here, next to each channel, there's 4 of those. That's actually a PWM controller. So that'd be for the switching charge and or load. And on the switching part of these, so there's 4 of these channels. That's a high side MOSFET, switching MOSFET. 3 per channel, 3 other surface mount ones with, you know, a little bit of PCB heatsink there. I don't see any via stitching or anything serious like that. So they're obviously not dissipating a huge amount. But yeah, but that's all pretty discrete stuff. But if the PWM controller is like all the way over here, I kind of don't get that. Like, you know, why it's not over here next to the switching stuff, I don't know. And check it out, next to the DAC here, I totally missed it. The PIC16F84, absolute classic. Why they've just whacked a little micro in there, right near some of the HC574 bus stuff for the HC11 micro up the top. That just seems out of place. I don't get what's going on there. Anyway, we've got some memory over here, but Yeah, why you'd need a PIC. So yeah, I don't get that. Why? Is it a separate micro that controls the DACs? Maybe they decided that they want, just dedicated loop microcontroller loop functionality of the DACs, perhaps? Meh. Anyway, I see some op amps down in there. There's a current shunt resistor there. That would be actual battery shunt resistor. But I'm not seeing any ADC per channel yet. There's got to be an ADC in here somewhere. Found like a bunch of DACs, but no ADC. Well, for the life of me, I cannot find an ADC on here. If I do later, I'll put it in the edit, but I cannot find one. So I reckon what's happening is there's a bunch of comparators in there as well. So I reckon what they're doing is they've just got like a reference somewhere, and they're just basically using the DACs to then create a voltage reference, which then they compare like end of voltage, like end of charge type level stuff. I don't think they're actually measuring it, and that seems very strange. Why you'd limit yourself? I don't know why you wouldn't go for a full ADC DAC solution. I'm not sure what the deal is, but damn it, I can't find. There is no ADC. There is no ADC, I swear. It's not here. Ugh. I've got to presume that they've got an ADC solution in there. So they're probably using the 8-bit DAC in there as a successive approximation converter, perhaps. And the power supply down there, well, that's a bit how you doing. Yeah, exposed cabling and everything. Like the grounding's fine. It's fine. It's just lacking a little bit of spit and polish, but it's it's good enough for the era, I guess. There's a better framing shot of the top half there, and yeah, we have a date code on this of 497. So 1997. The manual had 2005, but as we'll see in the manual in a minute, yeah, you know how I had those complaints about the thermals in this thing? It looks like they took my opinion on that and they fixed it way back in like the 2000s. So yeah, this is an older model of the, I presume, a much older model of the C7000 series. All right, let's power this thing up. I've got my 110 volt transformer, so let's give it a whirl. I don't know when it was last used, but here we go. Hey, flishy flash, copyright 95 2000, version 3.5 something, empty bat shop. Don't you hate it when your bat shop's empty? So you press the S1 button. Looks like it was previously used for a 7.2 volt NiCad, 1500 milliamp hour. That's, I don't know, is that like the last serial number, or is that the, lithium ion, there you go, 3.6. NiCad and a lithium ion there. I assume that's just some generic thing. And what? Charge, discharge rate? Oh no, these are arrow keys. Oh, oops. Okay, so once you're in, these are arrow keys. Okay, that's that's confusing. All right. Yeah, there we go. Up and down. Okay. I thought like this would just run S1 would be the primary function and just run like a macro, or, go through its pre-programmed thingamabob. Capacity offset, there you go. Temperature sensing. Max standby voltage, max charge voltage. End of charge, end of discharge. So menu, there you go. Security, system security, yeah, I thought so, yes. You don't want people dicking around with this. Voltage display. Sound control, output devices, calibration. There you go. Okay, so if we go to this lithium ion one, press C code to edit, and bingo, we're in. Can we, yeah, SLA, there you go, sealed lead acid, lithium ion, NiCad, nickel metal hydride. They're the pre-programmed. Okay, check this out. It is actually monitoring all the time, and when you plug in the battery, there you go. Well, no, bat shop's moved up the top. So, yeah, I guess we can then bat shop mode, S3 bat shop mode. Wait. So if I type 370, enter, it goes back to 3.6. Why? Is it because it's locked and I can't change it? How do we run it? I should RTFM, shouldn't I? Obviously, this is not designed for just, walking up and using kind of thing. Yeah, as I said, it's designed for like all pre-programmed factory production and service testing and stuff like that. Okay, I just figured out what BatShop means. BatShop is the battery shop software, PC-based software that they've got. So obviously it's in like PC interface mode or something. I think that's why it's not letting me do anything, but why I can't just manually start, I don't know. Whoa, the fan just ramped up. So it's temperature controlled. I didn't do anything. I haven't started anything. Anyway, yeah, it's clearly designed for the BatShop software. I couldn't find any option in there to like, reset to factory defaults to disable BatShop or whatever. But yeah, I think it requires quite a significant amount of time investment to try and figure out how best to use this thing, and download the software and all that sort of stuff. This video's been long enough. It was just designed as a teardown, so I have no doubt this thing will work. So yeah, if you want me to have a play around with this, I'll put any videos on the second channel, because I would actually like to get it up and working. So I would actually like to get the BatShop software working, so I can get like maybe discharge graphs and stuff like that, measure battery capacity and cell resistance and all sorts of stuff it can do. Real fancy pantsy. So yeah, I'll try and get that all set up. But that's it for this video. So I hope you like that interesting bit of industry kit. If you did, please give it a big thumbs up. As always, discuss down below. Catch you next time.